So, number 11 then from the 2015 Advanced Higher Maths, what have we got? Transformational matrices, 2 by 2 transformational matrices. And it just says write down M1. Now either you've just learnt them by rote, but it's much better just to generate them on the fly, especially if you can just visualise it. And one way of visualising would be this. Take the 2 points, the point 1, 0 and the point 0, 1. The handy thing about them is, if you put their position vectors down in order, the point 1, 0 and then the point 0, 1, that's the identity matrix. And if you want to transform those 2 points, then whatever matrix transforms them, the result will be this matrix, because you're multiplying it by the effect, by the identity element, by 1 effectively. So just think, where do they go under anything you want? So what do I want here? I want reflection on the y-axis. Well, this would go over to here. So 1, 0 would go to negative 1, 0. I need a new pen. But 0, 1 stays where it is. So that must be the matrix. What does it say? Second matrix associated with an anti-clockwise rotation of, so take that one away, an anti-clockwise rotation of pi upon 2 about the origin. So this one would turn down to here, and this one would assume its place. So what happens to 1, 0? It goes to 0, 1. What happens to 0, 1? It goes to, whoops, negative 1, 0. I know it seemed to take long doing that, but you can just visualise that in your head. Where do these 2 points go? And that's your answer. Then find the 2.2. Find the 2 by 2 matrix. Put a new pen after this. Associated with an anti-clockwise rotation, followed by. So you have to do it in the order. Followed by. So it's M2 first, and then M1 follows on after it. So that would be, well, M1 is negative 1, 0, 0, 1. M2 is 0, negative 1, 1, 0. Just a wee matrix multiplication, so that's the row times the column. So along the row down, 0 and 0, 0. 1 and 0, 1. 0 and 1, 1. 0 and 0, 0. So that would be it. So what's that associated with? Well, a little sketch will do again, just a wee sketch for this. So what happens to these 2 points? Well, 1, 0 goes to 0, 1, so it goes there. And 0, 1 goes to 1, 0. Well, they're just changing places, it looks like. They've been reflected. They're reflecting in the line y equals x. So what's M3? M3 means reflection in the line, I could just have said y equals x, couldn't I? In the line y equals x. Well, that must be the 4 points, eh? Those must be your 4 marks. 1, 2, 3, 4. Of course, you can always check that just with a wee bit of paper, or just even moving your hand. Or here's something I've got from the Hires sitting here. This should do it. What does this say? So you've got, well, I'll put it here. There's that graph of e to the x. It says you rotate it through 90 degrees, then you flip it over the y-axis, and lo and behold, there you've got the log graph, which is its inverse, which is it reflected in the line y equals x.